In the following video, we will learn how to use sine ratio to solve for the unknown sides of a right triangle. Trigonometric ratios are relationships between the angles and side lengths of a right triangle. The following right triangle can be identified by this 90-degree indicator in the corner. The side across from the 90-degree angle is referred to as the hypotenuse. The two remaining lengths are referred to as sides or legs. The hypotenuse can always be found across from the right angle, and it will always be the longest side of the triangle. The sides of a triangle are identified based on the angle you are working from. Suppose we are working from this indicated angle. The opposite side would be located here, directly across from the working angle, while the hypotenuse would be located here, across from the 90-degree angle. If the working angle were moved to this location, the opposite side would now be found here, and the hypotenuse would remain unchanged. In a right triangle, the sine ratio relates the angle you are working with to the opposite and hypotenuse side lengths of the triangle. For example, in this right angle triangle, working from this angle, the opposite side would be located here, while the hypotenuse would be located here. Let's use this information to solve for the unknown side of a triangle. In the following example, we are given a working angle of 42 degrees. The opposite side is unknown, and the hypotenuse is 18. Recall the sine ratio is opposite over hypotenuse. We can substitute the working angle into the expression, followed by the opposite and hypotenuse information. The x can now be solved for in this expression. In order to solve for x, we must reverse the operation taking place on the right-hand side. To do this, we multiply both the left and right-hand side by 18. This eliminates 18 from the right-hand side of the expression and gives us 18 multiplied by the sine of 42 is equal to x. In this case, x is equal to 12.04 units. This indicates the opposite side length is equal to 12.04 units. Pause the video and solve for the missing side length of this triangle. Here we're given a working angle of 37 degrees, an opposite side which is unknown, and a hypotenuse of 26. Recall that sine is opposite over hypotenuse. Substituting in the angle of 37 degrees, as well as the opposite over hypotenuse information, we can now solve for the x variable. Multiply both sides by 26 to maintain the validity of the equation. This eliminates 26 from the right-hand side. Simplification gives the expression 26 multiplied by the sine of 37 is equal to x. Completing this mathematical operation, we can see x is equal to 15.65. This tells us the opposite side length is equal to 15.65 units. This same procedure can be used to solve for the missing hypotenuse in a right angle triangle. Here we are given the working angle of 43 degrees, an opposite side length of 14, and an unknown hypotenuse. Recall the sine expression is opposite over hypotenuse. We can substitute in the angle we have been given, as well as the opposite and hypotenuse information. We can now solve for the x variable. Since it is located in the denominator of the fraction, there will be an additional step in solving. Let's begin by multiplying both sides by x. Simplification of this step reveals x is eliminated from the right-hand side and is transferred to the left-hand side of the equation. X multiplied by the sine of 43 degrees is equal to 14. There's one more step that must take place to isolate for the x variable. both sides must be divided by the sine of 43 degrees. This eliminates the sine of 43 on the left-hand side, revealing x to be equal to 14 over the sine of 43 degrees. Completing this mathematical expression reveals x is equal to 20.53. Therefore, the hypotenuse is 20.53 units in length. Pause the video now and solve for the missing hypotenuse length in this triangle. We can see we've been given a working angle of 54 degrees, an opposite side length of 31, and the hypotenuse is unknown. Recall the sine expression is opposite divided by hypotenuse. We can substitute in the angle given, as well as the opposite and hypotenuse information. To begin solving for the x in the denominator position, multiply both sides by x. This eliminates x from the right-hand side and gives the expression x multiplied by the sine of 54 is equal to 31. To complete solving for x, divide both sides by the sine of 54. Eliminating sine from the left-hand side, we get the expression x is equal to 31 over the sine of 54 degrees. Completing the mathematical operation, we learn the hypotenuse is equal to 38.32 units in length. In summary, there is a relationship between the angles and side lengths of a right triangle. The sine ratio relates the opposite and hypotenuse sides of the working angle of the triangle. You have now learned how to solve for the missing side length in a right angle triangle using sine ratio.